Okay guys, now to actually prove and get some practice in proving if lines are parallel or not. Like I said in the last video, you learned about the angle pairs. And the reason that we want to use those angle pairs or know about them and be able to identify them when we see two lines cut by a third line, which is known as a transversal. Lines are going to be parallel if corresponding alternate interior and alternate exterior angles are congruent. So to check, like these orange lines right here, if they're parallel or not, all we have to do is measure a pair of angles and check to see if they're congruent or not. We don't have to do every pair, just pick one and measure them, okay? Also, lines are parallel if their same side interior angles are supplementary, meaning they add up to 180 degrees. And we're going to prove these a little bit later. Right now, let's just kind of get some practice seeing if this makes sense to us. So we're going to check to see if these lines are parallel or not. So to do that, what we have to do is draw in some transversal that'll be like our guideline, right? Kind of show us the relationship of how these two lines behave. And where we put it, it doesn't matter. It just makes different angles, but it's the congruency or non-congruency that we're looking for. So even if I put my transversal, say, just like this, or maybe even try to go exactly perpendicular, we could do that. But I'm going to leave it like this, okay? Alright, so now to check to see if these lines are parallel, all that I have to do is identify and measure an angle pair. So I can measure a corresponding angle pair, an alternate interior angle pair, alternate exterior angle pair. It doesn't matter. So I'm just going to grab my pen and mark, say, this angle. We'll measure this one. And let's go with its alternate let's do its corresponding angle right here. Let's measure these two and see if they're the same. And if they're the same, then we can say, yep, these lines are parallel. If they're different, we can say, nope, these lines are not parallel. So I'm going to grab my protractor to measure angles. Okay, so let's measure this first one here. Let's see if I can shrink this little guy. Okay, so I'm going to measure this angle here. So I'm going to put the vertex right on that center part of my protractor where this angle is formed. I'm going to put one side of the angle on the 0 line, which means that I'm opening up to 10, 20, 30, 40, 50. So this looks like it is, if you were to extend that, I'm going to say 51 degrees. So this angle right here is 51 degrees. So if these lines truly are parallel, then this corresponding angle right here will also be, say, 51 degrees. And it looks like this is 51 degrees about. So I would say that these lines are parallel because those corresponding angles look like they're the same measure. So if this is 51 degrees, we can say, yep, these lines are truly parallel, right? Whereas if I made it so that they're not parallel, like these are now obviously, I hope obviously, not parallel. So if I were to, say, measure these angle pairs, again, those corresponding angle pairs, whoa, like this one, I'm just going to, like this, it looks like that angle is right around 55 degrees. I'm looking at right here, 55 degrees, whereas this angle pair looks like it's 48 degrees. So since using the protractor, it helps us determine this was 55, this was 48. So since these are not congruent, they're not parallel lines. I could have measured this angle and this angle to verify. I could have done alternate interior, like this angle here, and measured this angle here to check as well. But any of those angles pairs will show us whether lines are parallel or not. And when we translate, here's an example of translating. Right, when we translate an object in GeoGebra or in geometry in general, we need a vector to tell it how to move. So say like this vector. So when I translate this object by this vector, and then I show all the vectors, like A moved to A prime, B moved to B prime, D moved to D prime, C moved to C prime, your vectors, whenever we translate, will always, always, always be parallel because they have the same movement. But when we check it too with the transversal, and I measure all these angles, I hope you can imagine and see that the angle pairs are going to be the same. Okay? So good luck with your assignment, guys, and start proving and determining mathematically if lines are parallel or not.